All right. Welcome, everybody, to this session of Cloud Lunch and Learn. Today, we have cybersecurity expert Imran Roshan to present on compliance monitoring and security with GKE. So I will turn it over to you, Imran. Have a great session. Feel free to ask any questions in the chat on YouTube, and we will address those. I'll get those over to Imran, and we will, and we'll continue this going forward. So, thank you very much, Imran, and take it away.
Thank you so much, Dwayne. Uh, okay, so it's night here almost. So good evening, good afternoon for everyone that is joining from anywhere else. So my name is Imran. I am a cybersecurity architect. I mostly work in the field of containerized security, GKE security, and more into the containerized environments and microservices. So today, what I am going to share, or what I am trying to present right here, is the new shift that we are seeing in the industry that's really prevalent in the places that I have worked personally, as well as in the industry right now, and that is microservices, micro front ends, containerization, and so on. So I'll give a brief introduction about myself. This is me. I am Imran Roshan. I am from India, and I am a certified ethical hacker. I have a CCNA V7 certification. I mostly work in the field of cybersecurity, DevSecOps. And the fact that I am working in the field of cybersecurity and DevSecOps is the reason that is stated in the fourth point, and that is because I am lazy. Right, as automating things, making things more secure, making things more prevalent to the industry that is going on right now is my job to do on a day-to-day basis. Apart from that, I am a beatboxer. I am into music production as well. So that's more or less about me. So before we start with anything that we are going to discuss about what is the containers, what are the security features, and what are all of the nitty gritties and the jargons that we are going to discuss, let's just clear it out about what are the basics for a containerized environment, and why do we actually, or why am I speaking on something that is often overlooked as far as I have come across. And it can be a major deal, it can be a very devastating fault in the system, if you can put it that way. And we are talking about containerized systems, right? You're taking a system, you are packaging it inside of a very, very small environment so that you can manage it easier, you can deploy it really fast, you can run rolling updates, you can have zero downtime, and all the good things. So the basics, right? What so many of y'all might even know about it, but I personally like to run through the basics first. So, what consists of a containerized environment or a microservice based environment, right? So, firstly, there are the clusters, there, which comprises of all of the nodes, the control planes, the components. It's basically the environment that contains your containers. Inside of cluster, you might have nodes. So, it's basically a virtual machine that is of a very minuscule scale that hosts your application. The namespaces, idealizing an environment, it's like a virtual space where you identify yourself, or your application identifies itself as a Java application, as a Node.js application, as a Ruby application, and things like that. Pods are the group of containers with the guarantee that all containers in the pod are scheduled on the same node. And finally, there are the containers, the combination of C groups, namespaces, file systems, application dependencies, and all of these. So we're going to break this down into parts. We are going to break this down into each and every level, and we are going to talk about what are the cybersecurity features, or what are the things that we, as cybersecurity architects, we as even developers need to take care of when we are developing microservice based systems. But before we do that, what are microservices? right? So it's a shift for the people. Why do I want to put it as a definition that it is a shift for the people? It's helping us in the industry be more customer focused and increase the efficiency of our applications so that our customers, our endpoint users, are more efficient with what they are trying to do. And like, what are microservices, right? Deployment independence. So microservices is basically packaging your application into smaller workloads and running it in an orchestrated environment, something like Amazon EKS, uh, Google Kubernetes engine, Minikube. It might be on-prem as well. That's whatever suits your fancy. So why do we use microservices, right? The deployment independence, the ability to change our deployments, the ability to roll updates, the ability to bring a feature up, test, and then maybe take it down in the worst case scenarios if the feature does not work fine. The scalability. You want a feature today, you want a new application today, you are building that application. It's just the amount of time that it takes for you to develop the application. Deployment is just a matter of minutes. Agility. So you'll be able to facilitate continuous delivery, or what we call as CI/CD in this case, right? So since every microservice is independent in itself, yeah, it's independent in itself in the definition of what it does, but it's dependent on every single microservice that it packages itself with to bring forward the functionalities, right? So we'll go by that definition. It's independent in itself, and the delivery speed is valuable in today's world. And obviously the reusability. This is a key feature in microservices, where the components of a microservice, maybe the API call from one microservice, or maybe the data that is processed from one microservice, can be used by another microservice, right? Now, building on this information that we just discussed about microservices, we have something called micro front ends that is like a hot topic in the industry right now, right? It's a microservice testing approach that deploys your front end applications as a microservice, right? It's nothing to be concerned about, but it's nothing to be confused about as well. It's just the microservice architecture that is building your front end application. And this is where things get a little bit difficult. Things get a little bit difficult to manage, because front ends are an application that we need to be very focused on as the standpoint of cybersecurity comes into play, right? There might be XSS vulnerabilities, there might be CSRF, there might be token hijacks, there might be whatnot. Taking the entire list of OWASP top 10 or any other framework that supports your web application penetration testing cycle, there might be n number of vulnerabilities and CVEs that we might put forward, right? So over the time, this architecture that we talked about, the monolithic architecture, changed to front end and back end, where the monolithic architecture was a single point of failure. Anything that is going down, if you have to increase your resources, you have to go into the procurement life cycle, you have to get the resources, racking and stacking, and then you deploy. Whereas we moved to front end and back end, which were mostly on cloud. It was on, say, EC2 instances, or Google Compute Engine instances, or any other cloud providers that provide infrastructure as a services, right? So then, once again, there were some issues regarding single point of failure, regarding deployment time, rolling updates, and then we shifted to microservices. And now comes micro front ends. So, what I'm trying to portray right here is, with great power comes greater security risks. Kubernetes, uh, Elastic Kubernetes service, or Google Kubernetes engine is a really powerful tool when it comes to managing your clusters, when it comes to managing your microservices, or to put it in technical terms, orchestrating your microservices. So your microservices might have three major concerns that we put. There are a lot of more concerns, but these are the three that we'll be focusing on. Library scrutiny, and build independence. What do I mean by this? So you have the ability to make your application independent of code bases, right? There's no developers conflict that is coming into play saying I will develop this in Java. You can develop it in Java. That doesn't necessarily mean that I'm going to deploy my microservice, or I'm going to make my microservice in Java itself. I can make it in Ruby, right? So these code bases that are differing from one microservice to another comes with its own flaws. There are libraries that you are importing that might be malicious at the end of the day, especially if you are using some PyPy tools or something like that, or developing in Python. There might be some libraries that are outdated. There might be some libraries that are even vulnerable at this point of time. Secondly, we have the segmentation and segregation. All of these microservices that are segmented and segregated into different functionalities, different workloads, different types of processes that it might be doing, right? So if there is a process, or say, I'll give you an example saying that today I am asking someone that where do you live? He or she quotes a particular place, right? So say London. Oh, where in London? So I say that I randomly say one of the places in London. So she replies, no, I don't stay in this place. I rather stay in this place in London. That's the extra information that I did not need, right? Or the information that I didn't ask for. I just gained that information. This is where segmentation and segregation comes to a live example as well. Maybe I ask for an API call that gives me n number of informations, or say number of infos or number of IDs that are required. But I have a lot of information that comes from that API call as well, which is not of use to me. But my microservice still calls that. And if the channel is unencrypted in the middle, there might be MITM attacks. No one can guess that. Lastly, we have the authentication. Each and every microservice, whether I am contacting someone, or my microservice is dealing with an SQL database, my microservice is dealing with a MongoDB database, or my microservice is dealing with another microservice, all of these needs to be authenticated. Now, why authentication? Why am I talking about authentication? There are two major points that come here. One is hard coding credentials. It's very much, to be exact, it's a sad practice to hard code credentials inside of a code base. But to use a secrets manager is also fine, regarding the fact, or making sure of the fact, that a secrets manager is used properly. And that's what we are going to see in the following slides as well. So what we're going to talk about is the Kubernetes, or the K8s threat model. So the threat model comes with a set of infos, or a set of roles that actually, make sure that a threat model is made for the Kubernetes microservice environments that you're running. Firstly comes external attackers, people who have access to the cluster and have all of the services running in them, where IAM, or identity and access management, is key. So I have access, or I have administrator role, or I might have editor role for the project that my Kubernetes cluster is running on, maybe. So I might make changes, or intentionally or unintentionally try to make changes to the Kubernetes service that are running, in turn making havoc in the Kubernetes cluster. God forbid. But yeah, there are security controls for this, ensuring that the management services, for example, the API servers, kubelets, etcd, and other services, are not exposed to untrusted networks without authentication controls in place. The best thing to do right here is principle of least privilege. API server authentication, API server authorization, making sure your API calls are authorized before you get a response from that. Else, if someone else is calling it from outside of the cluster, he or she might get some kind of information that you don't want to be go out of the company, or something else that sort. And finally, there's the kubelet authentication as well. The next part in the KRS threat model comes the container paradox. So we have talked about microservices, we have talked about pods, we have talked about nodes, we have talked about containers that are running inside of the pods, and a lot of jargons right there. But what exactly is a container? A container is your packaged application. It comes with the operating system, it comes with the database if you require it as a sidecar container, it comes with the application code, it comes with the dependencies, it comes with everything packaged in itself, right? But containers are machines at the end of the day, and machines have vulnerabilities. Making use of these vulnerabilities to gain access to a cluster is as familiar for an adversary as gaining access to a physical system. Because at the end of the day, a container can be loosely translated to a virtual machine. The security controls for these, ensuring that all management ports visible on the cluster network require authentication. Once again, we come to the same square one of authentication. Ensuring that the service accounts are either not mounted in containers or have restricted rights. That is not cluster admin, right? So the service accounts or the authentication accounts as we use in maybe Google Cloud or AWS or anything, any cloud service provider, gives you the least privilege access, right? That's completely fine. That's good to go. But if I mount it on the container itself, that makes it a rather easy entry point for adversaries. Using network policies to restrict access between namespaces and pods, right? Your namespaces isolate your environments or isolate your microservice code bases. Maybe if you are making namespaces according to Java, Ruby, or something of that sort, or you are making namespaces according to front end, back end, DB, or so on and so forth, right? So making sure that these namespaces and these pods have the particular network policies. There are no open ports that they don't require. There are no services running that are not required by the container, and other network policies that might put into play. Lost keys. One of the most important aspects, personally, we have tackled these in scenarios where keys to an API or keys to a Kubernetes cluster were exposed out on the internet. So an attacker has valid credentials to execute commands against the Kubernetes API, right? So if this particular key or this authentication token or whatever we might call that is exposed out, you can obviously make authorized requests to my personal Kubernetes cluster. Security controls for these is once again authorization, RBAC, role-based access control policies that are in place for all users, providing the least privilege access to cluster resources. If your cluster is trying to access just one API, it should be granted access or authorized on one API itself. If it's accessing maybe a database or something of that sort, it should be authorized with the database and the database only. Just the amount of authorization or the amount of information that it requires, you have permissions for just that. Ensuring that the pod security policies are in place for all users to restrict the right of pods that can be created, right? All of the pods have their particular policies that might differ from company to company, that might differ from use case to use case. All of these policies should be taken care of. The HCD. HCD is basically the storage. HCD stores the cluster state, uh, including items like service tokens, secrets, service configurations. So it's basically the brain, or if you put it in that way, it's basically the brain or the soul behind this particular application that I'm running, right? So the exposure is somewhat limited, but never zero. Security controlling is using client certificate authentication. Now, This is what so securing base images. So I'm gonna emphasize on this point because the time that I have spent in securing containerized environments, researching out with fellow research mates about container security and what are the use cases that happened, or what are the fatalities that happened recently. All of those, or at least 80 to 82% of those, were base image vulnerabilities. And what do I mean by base images? Right? Each and every container seems to be a virtual machine at the end of the day. Each and every virtual machine has a base operating system, and that base operating system is what we need to secure first and foremost, because about 80% of the vulnerabilities that rise for a particular application, or that leads to maybe ransomware attacks, leads to information disclosure, that leads to a lot of vulnerabilities, are base image. So security at the very beginning, this is just using common sense. We are not using any tools as of now. So, are the container images signed and from trusted sources? You can't download maybe if it's from Docker Hub, that's completely fine. But is it a Docker Hub repository that is being managed by the application that you are trying, or the operating system, company that you are trying to download the operating system for? Or is it managed by someone else? It's managed by a single entity or someone of that sort. It's trusted or is it not trusted? Right. So these are all of the things that we need to take care of. Are the runtime and operating system layers up to date? Are you using the latest tag? Are you using something from back from 2016? How quickly and how often will the container be updated? This is a plan that you need to make in order for you to secure your containerized environment, in order for you to make sure that your containers are up to date and your containers are being updated time to time, the patch updates, the operating system updates, and all of the things that make you secure. And are security risks identified, and how will they be tracked? These are all of the monitoring techniques that we will be using. Let's discuss about a way that we can scan. So uh, tools like Trivy, tools like Falco, they can be integrated inside your CI/CD pipeline in order for whether you, it does not matter if you're using Jenkins or if you're using Cloud Build or something like that. You can always have some tools inside of that. So Trivy is one such tool. Trivy is open source. That is the reason why I like it so much. Trivy is a simple and comprehensive vulnerability scanner that scans container images, or your container images, for the base image vulnerabilities. It's Trivy is easy to use. Just install the binary and you are ready to scan. And all you need to do for scanning is specify a target, such as an image name of the container. So let's just see a quick example of that. I'll just go back. I'll open the terminal. Yeah, I've done some searches prior to the session itself. Turn to full screen. Yeah. So these are some searches that I did for two base images. We'll go through the commands in a little while. The point that I want to prove right here, it's as simple as I am not running the Docker daemon socket locally on this host machine. That is the reason I had to write such a big command right here. But the generic command is just Trivy image and the image name. So this is the command that I ran, right? It's scanning using aquasec Trivy the image Python latest, right? And is scanning. This is scanning Python latest. This is scanning Alpine latest, right? So What I need to see right here, it updates its DB. It makes sure to update its database to the CVEs and to the vulnerability database that is available right at this moment. And it gives you an entire scenario of what it's going on inside of your base image. The vulnerability, for example, CV 2011-3374, the severity is low. There are high severity vulnerabilities. So what we can do is trigger a exit code or trigger a function that stops a job from running or stops a build from deploying if there are, whatever suits your fancy, if there is one critical vulnerability and one high vulnerability, or if there are any critical vulnerabilities and any high vulnerabilities, right? So we can take the risk of low level vulnerabilities if we can, but we can see that there are a lot of vulnerabilities that needs to be taken care of for the package that I have talked about here, and that is the latest image for Python. For Alpine latest, these are the vulnerabilities that were found. There's medium unknown. But what if I scan for a completely different Alpine image? Let's copy this command, open a new terminal, and what we're going to do is we're going to go to Docker Hub, and we're going to take a previous image. We're going to take a image that is outdated or something of that sort. Let's go to page 4. Yeah, Alpine this. Let's copy this, go back to our terminal and paste the tag here. So it'll scan for the vulnerabilities. Let's give it some time to scan for the vulnerabilities, and till then, we're going to focus on this. Right. So what does it target? What does Aquasec Trivy target for? So it targets container images, file systems, Git repositories, Kubernetes clusters and resources. And for the scanners, it's OS packages and software dependencies in use, scans for the CVEs, the IAC misconfiguration, the infrastructure as code misconfiguration, if we are using something like Terraform in order to deploy our application, and the sensitive information and secrets as well, if anything is exposed out. So the reason why I scanned something of that sort, or something that like an old image, ah, what's a session without issues? Cool. Now, yeah, that's the issue there. Just bear with me for a moment. I'll clear the screen out. That should do the work. Yeah. So let it scan. Now, the reason why I'm showing you Trivy is because number one, it's open source. Number two, it's a really fun way to visualize what kind of vulnerabilities that we are having in our system. It's always better to view in command line interfaces. And the main reason why this is my tool of preference for this presentation is because it's easily integrable inside of CI/CD pipelines and your cluster configurations. But there are other ways. If you are using something like GCP, you can use the inbuilt base image scan feature that is packaged with the artifact registry or the Google container registry. That is completely fine, but I just find this interesting to view. Yeah. So till then, till the time that it's scanning, I'll just share this QR code on screen so that you can visit the GitHub page for Trivy and you can get your hands dirty with it. Now, the CIS framework, the rules for rulers. Right? So the CIS framework is something that we refer to on not necessarily on a daily basis, but on a regular basis. So the Center for Internet Security is releasing these benchmarks for the best practice in security recommendations for a Kubernetes environment. Right? There are CIS frameworks for Linux. There are CIS frameworks for EC2 deployments. There are CIS frameworks for anything that you can imagine that you are deploying your application on. But we are going to specifically deal with K8s for this session. So the CIS Kubernetes benchmark is written for the open source Kubernetes distribution and intended to be as universally applicable across distributions as possible. It does not matter if you are using Minikube on your machine, if you are using Google Kubernetes engine, or the Kubernetes service on AWS, on Azure, or anything of that sort. It's as global as it can be. So I've just zoomed it out a little bit. Yeah. So for starters, we have the initial access using cloud credentials, compromised images in registry. So compromised image in registry is something that is relatively new, that is relatively coming forth in news right now, because there are apparently people that package the same application with vulnerabilities and label it as Alpine Linux, as Python images, or as bundle images that are catering to your needs. But at the end of the day, they are vulnerabilities, and that's what we gonna take care of. The kubeconfig files, the application vulnerabilities, exposed dashboards. That's a deprecated technique right now. But if you're using a monitoring service inside of your Google Kubernetes engine, something like Grafana, something like Prometheus, those might be exposed as well if not maintained properly. Expose sensitive interfaces. These are new techniques that have come into play. For executions, there are exec into containers, the bash CMD inside of the container, running a new container, RCE, remote code execution vulnerabilities, SSH server running inside of the container, and there are a lot of deep dives that we can do on each of these blocks right here. So I think the scan is over as of now. Yeah, that's over. Cool. So the point that I had to make right here is I'm scanning a image. I don't know from when. It might be from 2017, 18, or something of that sort. It's Alpine version 3.11.7, right? So it's updated its databases and it has found critical vulnerabilities, high vulnerabilities, medium, high, and critical once again. So there are a lot of CVEs that we have in this result that we have received from Trivy. Whereas if I ran an image scan for the Alpine latest image right now, it has some of a medium vulnerability, or like a couple medium vulnerabilities and a couple of unknown vulnerabilities. So the rate at which the number of critical and high vulnerabilities decreased doesn't necessarily mean that they don't exist in this system, but they are not listed yet. If a new zero-day attack comes forward, or if a new vulnerability comes forward and is found in this system, they'll obviously have patches for that, right, at some point of the time. So the thing that is to be concluded right here is to update the base images from time to time, not use images that date back to centuries. So yeah, Kubebench. So Kubebench, or as I like to call it, the first line of defense for a container-based environment, something that is running on GKE, is something that is running on any other cloud provider or even on your local machine. Kubebench implements the CIS Kubernetes benchmark as closely as possible. So I don't have a cluster running here, but I have made sure to attach a screenshot from the observations. And the observations that we can see right here is info. There are failed, CIS benchmark uh, points right here. Ensure that the allow privileged argument is set to false. Ensure this, ensure that it adheres to the CIS benchmark and checks for all of the pass and fails in your Kubernetes environment. That's another QR that I would put forward, and you can scan it whenever you like, and you can get your hands dirty with the tool itself. Similar to these is a tool called ThreatMapper. So ThreatMapper is once again open source, once again you know a very nicely contributed tool from Defense. So Defense Threat Mapper hunts for threats in your production platforms, right? Similar to this tool is New Relic. I'll give you an overview of New Relic, and ranks these threats based on their risk of exploit or the probability of exploit. What are the vulnerabilities that exist in each and every microservice that is running, each and every container that is running, each and every cluster or the node that is running. It segregates it out to the even on the namespace level. The threat mapper, once again, a great tool. The QR code is here for you to explore the tool a little bit better. And yeah, before I move into this, let's just quickly see about New Relic. This is New Relic. So New Relic is a monitoring tool. It's free for a couple of GBs, if I'm not wrong. You can always refer to the documentation for that. It's monitoring my Windows desktop as of now. The CPU uses, the memory uses, the storage, the network traffic, and a lot of you know juicy information that you can get from your system. Right? You can add your data sources. Now, this is not only catering to Kubernetes. Let's just deviate for a minute or so. It has a lot of data points that you can integrate. It can be deeper networks, MariaDB. It can be syslogs, AWS VPC flow logs, GKE VPC flow logs, Algorithmia, Drop Wizard. It even has states for Trivy, Docker, Kubernetes, Pixie, and there are a lot of things that you can integrate. So if you're developing an application, let's not say that it's necessarily a microservice based application, you can monitor your application, or you can monitor even your desktops and your assets on something like Neural, right? It specifically comes with a Kubernetes feature, Kubernetes logs, and Kubernetes as the infrastructure, and it's relatively simple to install. Just say that there is a cluster name that you want to identify your cluster with, the namespace for the integration, hit on continue, and I'm just gonna type in some random spots. Let's just wait for this. And it gives you a guided install of how should you install this New Relic agent on your system. You can install it with Helm, you can install it with manifest file, or you can install it with the curl command. Similarly, for any other code base types that you want to integrate it with, maybe you want to integrate it with Java, Python, whatnot, C, Go, PHP, even, right? So it's integrable with all of those. Now, it's a secret that we are talking. Now, what is a secret, or what do I mean by this secret? It's not, a bread and butter terms of a secret. What I'm talking about here is a secrets manager for your Kubernetes applications, for your microservice applications, or your micro front end applications as well. So, container secrets. These are simple and secure secrets that are stored outside of your perimeter that you are working on, or your perimeter of processing, as we say. So, understanding what authentication and authorization secrets you need to control and where they are needed in your container is crucial, right? So, maybe I require authentication, or maybe I require a service account authentication to access MongoDB or MariaDB. I will not store it in my container, right? I cannot risk the exposure of these service accounts or these credentials. Rather, I'm going to store it on the HCD secret or the secrets manager that are provided by cloud platforms. But the main concern that comes here, or the main issue that comes here, is accessing these secrets. Yeah, it's fair, square, and simple that I'm going to access it from here. I'm going to implement it here, and I'm going to you know take it to the next step. I'm going to authorize, and then I'm going to get the data. But getting this data on an unencrypted channel, getting this data from a service account that has more privileges as what is it is designated for, can be a little crucial. So, learning how they are configured, stored, and managed can simplify the overall process of secrets management. If configured well, secret management makes your entire environment more secure. If not configured properly, it can be a pain. What are the caveats to this? Containers contain specific layers requiring security. The images, the containers that run on those images, the hosts that run on those containers, the application that runs on this entire system. There are a lot of layers to this. Each of these layers is constantly changing. Maybe you're updating base image today. Maybe you're updating the application today. Maybe you're updating the sidecar containers today. Maybe you're updating the secrets today. So these are all rolling updates. This is happening as we speak, right? So these changing in containers are dynamic and ephemeral environments. It can change at any point of time. May or may not revert back to its old state, and things might be lost, right? An application running in containers often need to access external resources such as APIs and databases at different times. So, how are we going to manage these? How am I going to manage a environment that is constantly changing? So, the things that we can do is, do not build secrets into the container image, right? Store it somewhere else. Store it in a secure, system. Maybe, uh, envelope encrypted. To access container secrets, it may seem logical to build the secret value into the code or the container image by defining it in the Docker file, but that is wrong. However, this means that anyone with the access to the source code or the code base now has access to the secrets as well. So, what we need to do right here is rotate the secrets, change passwords, and store it in a storage that is trusted and not accessible by everyone. Avoid using environment variables for your sensitive information, the .env files that we disgrace right now. But yeah, those are important as well. But storing information like database credentials in env files are not recommended. Sorry for that. Yeah. So it could be as easy as running Docker inspect or Docker exec in your containers for hackers to find your secrets. When using Docker Swarm, lock your swarm to protect its encryption key. Regardless of where you store your secrets, whether it be in a secrets manager, whether it be in an on-prem system, whether it be in a sidecar container maybe. So which containers need access to each of your secrets should be authorized. Maybe using service accounts, maybe using IPs, if provisioned that way, should have a particular authentication associated with it. And that is where we implement the last point, that is role based access control, adhering to the principle of least privilege, where an application only has access to secrets that it needs, no more, no less. And it's easier than it sounds. So what I did right here is listed a couple of commands that are specific to GKE to create a Docker registry, registry key inside of Secrets Manager for Google, and then accessing it, right? So what I did right here is kubectl create secret Docker registry, my registry key, and whatever the dummy, server IP address, password, and email might be. And I've created a secret for that. And all I need to do now is patch my service account to this secret in order to pull my images. And it's as simple as two commands that are stated right here. Now, it's better to have multiple service accounts for multiple processes that you might be doing, and that's relatively easier, might be a little tedious in prior installations, or it might be a little tedious for implementation for the first time, but it's going to pay off in the long run. Now finally, perimeters. So perimeters is where we define the limits, we define the scope. Now, why are we taking the hassle of defining perimeters? Why am I, creating VPC perimeters? Why am I creating container perimeters? Why am I creating service accounts? Is to maintain one and one solution only, and that is principle of least privilege. Separation of all of the duties that are contained inside of an application gets the permissions to fulfill those duties and those duties only. So we'll come to this. Yeah. So the main agenda of this entire time that I spoke about is to just make clear about all of the things that we need to do in order to secure a microservice environment, because these are the bare minimum. These are like the baseline of what the industry needs right now. Yes, there are a lot of things that can be built, but all that can be built is built on top of these baselines. The reason why I chose cybersecurity is something that is quoted by this person called Monkey D. Luffy. So it's an anime character from One Piece, just in case. So yeah, if an old man tells me anything, I will quit being a pirate. It's a boring adventure. I don't want to do it. And that is the reason why cybersecurity is so interesting. There might be something tomorrow, there might be something today that I'm not aware about, that I might come to know tomorrow. And that's the entire adventure that we are seeking for. And that is what cybersecurity is at the end of the day. That would be my talk. And thank you so much, everyone, for listening. Thank you so much, everyone, for joining in. These are my socials in case we want to connect. And that would be it. Thank you so much.
Very well done. Excellent, excellent talk, Imran. Very, very intriguing, and love the little secrets and everything that you provided as we went through. So I want to thank you very much for joining today
Thank you
and
so much.
providing the great information. And thanks everybody listening in here on Cloud Lunch and Learn. And until next time, have a great day and enjoy the content that we have. This talk will be available on the Cloud Lunch and Learn YouTube channel, as well as all of the other talks are. So thank you very much again, and have a great day.
Thank you so much.